Alright, we're going to talk about quadratic application number 3. A baseball is thrown into the air for t seconds. The height of the baseball is in feet and is given by this formula. And the formula is y equals f of t equals negative 16t squared plus 64t plus 3. So I always like to sketch what this is going to look like. I see that it's negative and I have a 2 here, so it's a quadratic, open downwards. Life is in quadratic 1, and I just lost the place that I was at, so let's go back. Quadratic 3. So let's draw the picture of this. So, quadratic, life is in quadrant 1. Okay, and this one's going to be a little bit different than the other ones because I know time is in seconds, so I can label that. I know that this is the height in feet, and they called this f of t in this case, which is the height, and it's in feet. So you're like, well, how's that different? Well, I know right now, when time is 0, if I were to put a 0 here and a 0 here, these would be gone. I have a 3. Because in real life, if you throw a baseball, you don't get on the ground and throw it down here. You're going to throw it from a certain height. In this case, this one was thrown at 3 feet. So I know I'm going to throw the baseball. It's going to come up and it's going to come down. Maybe not that much, but it's still going to have a max height and it's going to come and hit the ground. But it's going to hit at 3. Okay? Now this is why I wouldn't let you before just double it, because if you'll notice, part of the parabola kind of goes here in this quadrant. And we really don't care about that because that's when time's negative. But you'll see when we go to solve for this, you'll see a negative value, and it really has no meaning in this problem because time is only positive, and we only care from when time was 0 to here. Alright? So we want to know when it's at its max height, so we're looking for the time. Max height again is your axis of symmetry, because you want to know when it's at the max height. How high does it go? So you want to know the height. And how long does it take to reach the ground? And that's when the height is 0, and we're looking for the time again. Now these should be getting familiar to you because we've done a couple of these already. Okay, so let's go through and do this one. Okay, there's my little picture. Let's start with A. First thing is, when is it at max height? Well, I say x equals negative b over 2a equals negative 64 all over 2 times negative 16. So that comes out to be 2 seconds when I put it in my calculator. So now I know at 2 seconds, this is at its max height. So there's my axis of symmetry. Now, of course, they want to know when, or excuse me, how high that is. So if I know at 2 seconds that's the max height, I'm going to take that 2 seconds and plug it into my formula, find f of 2 to find out what the height was at that time. So I'm going to throw my 2 in my formula. When I put that in there, that's 67 feet. So that's the highest that ball goes, is 67 feet. So as you go along, you should label this picture, and it makes sense to you. So the point 267 is on my graph. Okay. For the C part, I'm going to take this down to the other thing right here. So I'm going to do C. So here's my formula. They want to know when it hits the ground, so I take the formula that I had on the other page, and I'm going to put it equal to 0. And I want to know when it hits the ground. So if A equals negative 16, B equals 64, C equals 3, D is going to be b squared minus 4ac, or 4288. So I've got my time, or x equals negative b plus or minus the square root of 4288 all over negative 32, or 2a. If I split this up as positive and negative, when I use the positive, I get a negative 0.0463 seconds. That's what I was alluding to before. That's in the other quadrant. So that we actually kind of reject that. But that's when your formula in your calculator does not know that you're talking about a ball in the air. So it's going to give you 2 roots. It's just this doesn't mean anything in this problem. When I do the minus, I get 4.04034 seconds. And that's when it hits the ground. So that's what we care about right there. So I have at 4.04. See how it's a little bit different? It's not exactly doubled. Now I do want to show you a trick here on this, the calculator on this. So I'm going to bring up the calculator on here, and I'm going to actually graph this. So we're going to go home. We're going to do a new document, and I want to save changes. I'll say no. So let's put in this. We're going to add a graph. I know there's all 4 quadrants there, and remember what I told you, never use t's in your formula, use x's. So I have negative 16 x squared plus 64x x plus 3. When I hit enter, it looks weird. I know I've got all this, so we're going to change our window. We're going to go to our menu, we're going to go to our window zoom, go to our settings, and we're going to start at 0. And we know that it hits the ground. We already figured this out, that it hits the ground a little over 4 seconds. So this makes this look a little nicer. So I'm going to delete this and make this maybe 8, just so the window looks nicer. Here, the Y min, we're going to delete that and put that 0 because we care about quadrant 1. And we know the max, because we've already done all the math, the max this ball gets to is 67 feet. So I'm going to put 70 feet in there. And click OK. Now we can see this nice picture of this graph. Now I want to show you that some of the things that we just found that you can do by looking at the calculator, so you can check it on a test or a quiz. So the first thing, we're going to analyze the graph. When you hit analyze the graph, we can do a lot of things here. We're going to do the first thing is maximum. Okay? When you do maximum, your calculator will have this little finger here, and the maximum, you want to have a lower bound and an upper bound. So you want to go to the left of it. Okay, and then it'll ask for the upper bound. You want to go on the right side of the maximum. As soon as you do that, look what it gave you, the 0.267, which means in our graph at 2 seconds it was 67 feet high, which we already found with our algebra. So it kind of gives you the answer so you can check your work. Okay, other things we can check. We can check and analyze the graph. We want to know the 0. Okay, so you want to know the lower bound. So we go on the left and we go over here and hit the 0, and it tells you at 4.05. Isn't this calculator wonderful? So it will tell you all the things. So I want to make sure that you show me all the algebra to this, but you can definitely check it on your calculator. And I thought that was pretty neat, and I wanted to show that to you. Okay?